Okay, we're going to be looking at some special parallelograms today, but before we do that, I'd like you to take a moment and remember the properties of parallelograms from a couple lessons ago, and go ahead and fill in those blanks, 1 through 5. Hopefully you got them all. So most of these, all except for number 5, the diagonals, deal with the sides and angles. So to make some special parallelograms, what if we do special things, or one particular thing, to the sides for one and the angles for the other? So let's talk about the sides first. So if the sides of a parallelogram are congruent, what do you think that forms? Well, think about it. If we have a parallelogram with 4 congruent sides, we've seen this before, this is a rhombus. Okay? So remember, a rhombus is not a square. It just has 4 congruent sides, period. Okay? So we want to be careful with that. So let's define this. It's a parallelogram with 4 congruent sides. And just like I was saying before when we were proving we had parallelograms, you need 2 things for rhombuses too. You need to know, number 1, it's a parallelogram, and number 2, it has 4 congruent sides. How do you know if it's a parallelogram? Go back to those conditions. So those other pairs of things you had to know, like both pairs of opposite sides are congruent, both pairs of opposite sides are parallel, etc. But in order to define a rhombus, we need to know it has, it's a parallelogram with 4 congruent sides. Okay? Cool. Then notice what happens if we do something to the angles. So if the angles are congruent, then it forms what? So if I need 4 congruent angles in any quadrilateral, what kind of measurement would that be? Well, remember, if your angles are congruent, 360 divided by 4 tells me each angle is 90 degrees. So that's what makes this a rectangle. Okay? So by definition, a rectangle is, again, a parallelogram with 4 congruent angles that happen to be 90 degrees. But when we're proving that that a shape is a that a shape is a rectangle in the next lesson, and when you're determining if something's a rectangle, again, 2 things: parallelogram, 4 congruent angles. How do you know if it's a parallelogram? Go back again to the conditions for parallelogram, so the other pairs of information. Okay? Then finally, as a side note, if a parallelogram is both a rhombus, oops, not a rhombus, a rhombus, and a rectangle, then it's a square. So rhombus by itself is not a square, a rectangle by itself is not a square, but if it's a rhombus and a rectangle combined, then it is a square. So a square has 3 parts to it. It's a parallelogram, that has 4 congruent sides and 4 congruent angles. So that means a square will have all the characteristics of a parallelogram, a rhombus, and a rectangle. A rhombus will have all the characteristics of a parallelogram and some of its own, and a rectangle will have, again, all the characteristics of a parallelogram and some that are unique to rectangles, which we'll talk about in a moment. So the rest of this video I kind of cut and paste from a previous year, so bear with me if there are if there are jumps or pages doesn't look completely the same. The content should all be there though, okay? Okay, we've got 3 properties of rhombuses we want to use in our work today. Let's talk about the first one. So the first one says if a quadrilateral is a rhombus, then it's also a parallelogram. And that kind of makes sense with our title, right? We're talking about special parallelograms. Okay, so again, if we have a rhombus, then we have a parallelogram. So if you look at this diagram, again, I can tell it's a rhombus because of these four congruent sides. Or I could tell you in words, right? A, B, C, D is a, oops, let me make that a little cleaner, is a rhombus. And if we know that, then we know ABCD is also a parallelogram. And that means those five properties we just talked about up here, they're all true for rhombuses too. So we could say BC is congruent to AD. Well, actually, we already knew that, but we could say angle B is congruent to angle D, right? Opposite angles are congruent. Your diagonals would bisect each other, all that lovely stuff. Okay, the second property, the second theorem says that if a quadrilateral is a rhombus, then its diagonals are perpendicular. All right, so again, if we have a rhombus, now we can say the diagonals are perpendicular. So what that does is that creates angle measures for us. So we would be able to say the diagonals AC and BD are perpendicular. And this is great because remember, perpendicular gives you what kind of angles? That's going to give you 90-degree angles. So we're going to be able to say, right, in ABCD, these are all 90-degree angles, which gives us right triangles, which gives us a 90-degree measure. That's great for doing Pythagorean theorem. It's great for proving triangles with HL. So that's something neat to go with our proofs. Okay. Next, our last property that are specific to just rhombuses is that the diagonals each bisect a pair of opposite angles. Okay, so what that means is that the diagonals, right, AC and BD, are going to cut their opposite angles in half. So obviously AC is going to cut angles BAD and BCD in half. BD is going to cut the angles it intersects in half. All right, so oops, let me fix that. Let's go ahead and write that down. All right, so first I can say that angle ABD and angle CBD are congruent, and this is created from that diagonal BD. So just a side note here. Angle ADB is congruent to angle CDB, again, because the diagonal bisects each other. And that's these angles right over here, right? So ABD, CBD, ADB, and CDB. And we can say the same is true for the other diagonal. All right, and this is created from that second diagonal, diagonal AC. And again, you can see that in this diagram right over here to your left. So let me draw these in as well. So we would know that BAC is congruent to DAC, and also BCA is congruent to DCA. And you'll notice those bisected angles are all the same because your opposite angles are congruent since our rhombus is also a parallelogram. So that's a great connection between the two. All right, so let's move on to example 1. Let's take a look at this rhombus MNPQ, and I realized I just forgot to write down those letters, but that's a rhombus, and the measure of angle N is 120 degrees. Let's find all the other angle measures. How do we do that? All right, so just draw those, write those letters in, draw those congruent marks, and we know a measure of angle N is 120, so I'm going to draw that in. Now, how do I find the rest of these angles? Well, if I think the definition of rhombus doesn't tell me anything about angles, and I only know angles that deal with the diagonals, so how do I figure out the angles of the opposite angles or whatever in this rhombus? Well, remember that very first theorem. If you have a rhombus, this is also what kind of shape? A rhombus is also a parallelogram. So think about what you know about angles in a parallelogram. 1, your opposite angles are congruent, and 2, your consecutive angles are supplementary. So we can use that. Oops, let me clear that up. That's supplementary. Okay. So we can use that information now to figure out the rest of these missing angles, right? So that means angle N needs to be congruent to angle Q because we have opposite angles. So that means the measure of angle Q is 120 degrees. Measure of angle Q is 120. There's one. Well, since we know our consecutive angles are supplementary, we would know that the measure of angle N plus the measure of angle P should add up to 180 degrees, right? So plugging in 120, I can figure out the measure of angle P is 60 degrees. All right, and we're almost done. Since angle M is congruent to angle P, since our opposite angles are congruent, I can say the measure of angle M is also 60 degrees. So there's 1, 2, 3, those last three angles. Okay, let's take a look at example 2. TVWX is a rhombus, so we know all four sides are congruent. Let's find each measure. So how do I find TV? If you notice, I'm not given anything about TV. I'm given information about TX and WV. But what did I just say about rhombuses? What do you know about rhombuses and their sides? Well, we said all four sides are congruent, right? So WX should be congruent to TV, which is, or excuse me, congruent to TX, which should be congruent to TV, which should be congruent to WV. So since TV is congruent to all the other sides, if I can just figure out one of those sides, I'm solid. And how do I do that? Well, let's go ahead and solve for B and plug in our information for B. So 3B plus 4 should equal 13B minus 9. All right, so there's B. We get 1.3 or 13 over 10. So once we know B, we can plug it in to find, for example, TX, which is 3B plus 4, right? And then use that to find TV, since they should be the same thing. All right, since TX is 7.9, that means TV should also be 7.9. Okay, looking at the second part, before I do that, I'm just going to go ahead and erase those highlights so I can use a diagram again with the angles. All right, so now we want to find the measure of angle VTZ. Well, first let's figure out which is the angle VTZ. Well, VTZ is this little one right here in the upper right corner. Well, what do I know about that angle? Well, since this is a rhombus, the diagonals are going to bisect opposite angles. So that means this angle VTZ is congruent to this angle XTZ, right? All right, so I know that then that the measure of angle VTZ is 5A minus 5. I'm getting closer, but I don't have a number yet. Now the question is, well, how do I find A? Well, where else do you see A in the problem? Well, I see A right here, this 14A plus 20. And that points at this angle right here in the middle. And do you guys remember what are the diagonals in a rhombus? They not only bisect the opposite angles, but they also make what kind of angles in the center? Well, they make 90-degree angles because these are perpendicular, right? So since XV, oops, sorry about that. Let me scroll back down. So since XV, that diagonal, is perpendicular to WT, we know that the measure of angle VZT should be 90 degrees. So I can use that to solve for A, then plug it back in to solve for the angle VTZ. All right, so I'm going to solve for A by plugging in 14A plus 20 right over here, and then I get A equals 5, plugging that in to get angle VTZ, that measure being 20 degrees. All right, so make sure you come back to class with questions if you have any questions on these. I know these can get a little complicated because you have to look at a couple pieces together. We're going to skip over the proof because I'm going to go over that with you when you come back to class. Now let's go ahead and talk about rectangles. Our first property of a rectangle is going to be very similar to our first property of rhombuses in that a rectangle is also a parallelogram. Okay, so if a quadrilateral is a rectangle, then it's a parallelogram. How do I know if it's a rectangle? Look for these four 90-degree angles, right? So that tells me ABCD is a rectangle. And if I know it's a rectangle, then ABCD is a parallelogram, which means those 5 things, I'm not going to scroll up this time, but those 5 things at the top of your front page are all true for rectangles. So opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, diagonals bisect each other, etc., etc., etc. Okay, cool. Then we have one other thing that is true for rectangles. So by making those 4 angles 90 degrees in our quadrilateral, not only do we know our rectangle is still a parallelogram, but we also know that our diagonals are congruent. All right, so now if I know I've got a rectangle, not only will the diagonals bisect each other because our rectangles are parallelogram, but we also know that our diagonals are congruent. So that means AC is going to be congruent to BD. And again, that's only true for rectangles. Please note this does not mean the diagonals bisect the angles. That's the common error I see over and over again with this. That's only true for rhombuses.